For this warm-up, look back in your notes and think about how are you going to set up cylindrical shells. Our goals, just a reminder, homework due Friday is volumes by discs and washers. Homework due Monday is volumes by shells. And next Friday, you have exam number 2. There is already a worksheet to practice online if you want, but we're going to do a lot more review techniques and stuff. In recitation, you have review tomorrow, and then you'll have review next week, so lots of review for us. Group quiz next Wednesday, so we have lots of good stuff. I do want to remind you, in recitation, you have a video this week, so this is video week. This week's video is about grit and growth mindset, and it's excellent, 2 excellent researchers. There are some videos from 2 excellent researchers, Carol Dweck, and oh my God, my brain is just going away from me today. I have to think who the other person was. Angela Duckworth. Those are the 2 ladies. One from Stanford and one from University of Pennsylvania. So we have 2 cool videos to watch. If you pick one, pick them both. But we're going to talk about cylindrical shells. So take a couple moments to do a review and look back in your notes. And we will talk cylindrical shells here in a moment. So I will just make a note that since we are revolving around the y-axis, shells cut perpendicular to x-axis, and hence both your limits of integration and all of your functions and everything have to be represented in terms of x. So see if your picture's matching my picture. E to the x passes through here, and then about 2.7. No, when it's 1, it goes up to about 2.7, somewhere up in there. And that goes like that. What's e squared? E is about 3 squared, a little less than 9. Is it 8 something? E squared, does anybody know? E squared. 27 squared. 7.389 e squared. Yeah, okay. I'll just write that down. You guys shade that region in like I have. E to the x, that exponential function that goes upward. X equals 1, x equals 2, vertical lines. Y equals 0, horizontal line. You're sending it around the y-axis. So you're getting this shape. Right? We have this shape. So if we're looking for this shape, it's going to be like this bowl, except it's got a bottom on it. Oh, wrong, Tina. It's got a big hole. What am I thinking? It actually has a big hole. It actually has a big hole. That hole... Hang on. It's got a weird shape now that I think about it. Hang on. It goes down to here. And then it comes down like this. And it makes this hole. So it actually keeps going down as a hole and as a funnel. So actually, I kind of like, it's like a cylinder. You can't see that. It's like a cylinder, and it's like taking a goblet out of that cylinder. That's how I'm seeing it as, like this goblet that I'm pulling out of a cylinder and have this thing. So what you're left over with is the cylinder where the goblet came out of, kind of thing, the mold. Yeah. You guys get an integral for me. So on your test next week, also later today and on recitation tomorrow, one of the first things you're going to do is to make the cut to make the cylinder. Because what are we cutting perpendicular? We're cutting perpendicular to the x-axis. So we want to draw a cut through that region. And then draw in the cylinder that corresponds to that cut. So that cut makes a cylinder that goes around my axis of rotation. You will be required on your test and on recitation tomorrow and today to make a cut and show that cylinder if you're using shell method. Show that washer if you're using washers, okay? Whatever you're using. And why do I want that? Because I want us to get used to identifying the pieces that are inside that cylinder, namely the radius and the height. Because remember, cylindrical shells is all about the formula 2 pi r h, which is the surface area of our cylinder. Okay, who wants to give me the integral? What'd you guys set up? Who wants to give me your integral? Volume equals. Who wants to go for it? Quinn? Yeah. Okay, I'm going to go part way. Just the black part. Just the black part. Just your shaded region for me.
Just the shaded.
Yep. That's okay. 1 to 2. Beautiful. Beautiful. Do you see that? Learning moment. Just the black region. Good. And then?
Pass to somebody else.
Okay. Good. I like it. Do you see why it's 1 to 2?
Yes.
Okay. All right. So this is really important, everyone. I know our region goes all the way around, and a lot of students have this trouble. When you go to integrate, you are just going to focus from 1 to 2 because each one of these is going to create a cylinder, and this part of the cylinder will take it all the way around. So we will get the entire shape by just going from 1 to 2 because we're going to catch the surface area for all of it as we move. One gives me an inner cylinder, and then the next one gives me the next cylinder, and we'll stack these cylinders, okay? 1 to 2. Cool, who wants to go? I know, it's warming up our brains. So we got 2 pi r h. Megan, go ahead.
X and then times e to the x.
Yes. Okay, let's try it. So let's take a look here. Height is defined right here. So it's top function minus bottom function. Radius is defined here, and we said our radius will always match our variable of integration. Unless we're going around a different line. So that looks like my setup. The height is e to the x minus 0 or e to the x. My radius is my variable of integration. Who has questions? Questions? By the way, how would we integrate this sucker? What method would we use? Integration by parts. We would use parts. Absolutely, we would use parts. Did anybody do it out by any chance? Let's practice. Might as well practice. That means we don't have to practice later when I give you the worksheet for today. So let's go ahead and let's practice integration by parts. Integration by parts. U is something, dv is something. Reminding ourselves how to do that integration technique. U dv minus v du. Did you have it already, Julia? Good job. You have it.
No, I did it wrong. I was using the wrong formula.
Oh, you were using, I understand. I see what you mean. I see. Who has questions? Who has questions? Yep, 2 pi out, absolutely. I would take out 2 pi. And then u is x, dv is e to the x. It what's e to the 0? E to the 0 is 1, right? E to the 0 is 1. Don't lose that piece. How are you, okay? That's good. Let's see. So we're going to let u equal using integration by parts. So let me just put a little note. We're using integration by parts. That's because we have a product of two functions. No u substitution. So u equals x. du is dx. dv equals e to the x dx. An antiderivative of e to the x is just e to the x. And our formula is uv minus the integral of v du. So we've got uv minus the integral of v du. Whoops, from 1 to 2, Tina. And that's just going to be 2 pi times. And the antiderivative of e to the x is just e to the x. So we have 2e squared minus e squared minus 1 e to the 1 plus e to the 1. Oh, that just goes away, doesn't it? Oh, yes. I think I walked around, now that I think about it, maybe. I think somebody might have integrated from 0 to 2 if I saw the papers. Be very careful. Your limits are 1 to 2 because your region is only going 1 to 2. Now that I think about it, I think I saw 0 somewhere. So we're only going from 1 to 2, okay? And so those e's cancel at the back end. 2e squared minus 1e squared is just 1e squared. Your answer, as weird as it is that what you got, Munia? Griffin? 2 pi e squared is Quinn? 2 pi e squared?
Yes.
Cubic units. Awesome. Who's got questions? Okay, guys, we're going to do one more of these practices, and then we're going to take it around a different line, and then we're going to put it all together with disc washers and shells, okay? So we're going to do one more practice of a cylindrical shell here. Use the method of cylindrical shells to find the volume of the solid obtained by rotating the region bounded by the curves y equals the square root of x minus 1, y equals the square root of 2, x equals 0, and y equals 0, this time about the x-axis, okay? So first thing again, on the test, I will give you the picture. Y equals square root x minus 1 is just your square root function, and you could get it by plotting some points. But it is your square root function shifted over 1 unit. Y equals square root 2. Oh, I don't have to go very far, huh? I actually don't need to go that far. Y equals square root of 2 happens when 2 is equal to x minus 1, or 3 is equal to x. So when x is 3, that's going to give me square root 2 on the y-axis. And so, I think we're going to create an interesting shape here. This is more like what I tried to do last time, I think. So the shape or the region that we're talking about is this region right here. And so before I even rotate it, I want to take note. This is my region that gets rotated. This is the region that's going to contain my limits for integration, okay? And it also identifies and tells me, since I'm going around the x-axis, when I go to make my cylinders around that x-axis, those cylinders have to be sitting sideways, which means I'm cutting perpendicular to the y. So I'm just going to put a little note. Since we're going around the x-axis, we are cutting perpendicular to the y. That means we're going to use dy, and our limits are going to be y limits, and you got to pay attention to where your thing is going on the y-axis. So I'll just highlight that I see that my region is going from 0 to square root of 2 on the y-axis. So I'm just setting things up here so that I know when I'm going to set up my integral. Now we're going to rotate that shape around, right? He comes down. Not that far, Tina. Not that far. And it goes like this. Comes around. Whew, okay. So we've got a shape with a little bit of gouge at the top, like a big hole goblet. Not a I meant like a big little thing coming out of the top. I do need to get clay and make these shapes. That would be fun to just sit there and give everybody these clay balls and Play-Doh, and then you guys could just create the shapes. That would be fun. Manipulatives. Anything you need to help you out here. You're going dx or dy, right? Because we're going around an x-axis, we're cutting perpendicular to the y-axis. We've got dy going on. 2 pi rh. You got to find r and h, so everybody make a cut. You make a cut for cylinders. Cylinders cut. Parallel to the axis of rotation. And if this is just getting you, and some students just 3D stuff boggles their mind. I know it. I've seen it. Okay? If this is just not clicking, come sit with me in my office and we will practice things to try and make it click. Okay? We will try and discover ways to make this click. So when you draw your cylinder in, you can identify the height for that cylinder, and you can identify the radius for that cylinder. And remember, the height will be defined by functions. The radius is always the variable of integration. You do need to switch things over, right? I think everything's written y equals, so we have to flip it to make it x equals in order to get our curves, right? Because we're going to integrate with respect to y, we need to change y equals square root of x minus 1, and we need to change it so it's y squared equals x minus 1, or y squared plus 1 equals x. So again, if you do want to sit and come visit me on Friday in my office, I'll be there before 11, I'll be there after 12:30, before and after class. Hours. We can just sit all day and practice these if you need before the weekend, before you get these improper integrals. How's everybody feeling on this? You guys got an answer for me? What'd you get? 4 pi? Some people are getting 4 pi. Is that what you guys are getting? Did you get 4 pi? 4 pi? 4 pi cubic?
The exam's next Friday.
It is. And if you want to take it early, let me know. Yeah. So let's see. Okay, so some people, how many like this stuff? How many people like this? It's cool. It's kind of fun. I love this. I love these. 2 pi. What's your R value? Munia, what did you use for R? Y? And what was your height? Y squared plus 1. Beautiful. dy. Very nice. So when we go, we can pull out that 2 pi. And then it's just y to the third plus y. And this one's super duper easy because it's just power rule. So it's 1/4 y to the fourth plus 1/2 y squared. 0 to 2, square root of 2. Guys are plugging those in. You get 1/4 square root 2 to the fourth plus 1/2 square root 2 squared minus 0. Everything goes to 0. So make sure everybody gets the following. Square root of 2 to the fourth is square root of 2 squared. That's how I'm going to think of it. Because square root 2 squared is 2. 2 squared is 4. Oh, that's 1. That's 1. That's 2 pi times 2, which is just 4 pi cubic units. Alrighty. I'm going to stop. Let everybody absorb. And let me know if you have any questions before we talk about taking that and moving it around a different line. Munia, question.
You said you wouldn't take points off if we don't write cubic units, right?
Correct. You don't have to write cubic units, and I won't take points off if you don't. Any other questions, guys? Patrick, question?
I wasn't here Monday, so what determines the radius?
Good question. In fact, once we do the next guy, it'll make a little more sense. So the radius, thank you for asking that question. So the radius, when you're using shells, if you notice when you're using shells, the functions that are bounding the region are determining my height. So the functions are determining my height. The radius is determined by where I make a cut. The thing is, this cylinder is just a random cylinder. Maybe I chose to make a skinnier cylinder cut. I just randomly chose this cut. In fact, I have to hit cylinders all the way along this axis. I can cut it here, I can cut it here, I can cut it here. I have to actually make cylinders to fill in and expand the whole region. And as I'm making my cylinders, I'm moving and making them wider, and the width is changing along the y-axis for this particular example. So this is actually a cut right around 1/2 units wide. My radius is about 1/2, but it matches the y value where I'm cutting. Maybe I'm going to make a cylinder right here that's only 1/4 radius wide, but it matches the value on the y-axis. So the radius in a cylindrical shell is simply your variable of integration. I lost it, it's up there. So your radius on a cylindrical shell is simply your variable of integration, unless you're going around not an axis, but going around another line. Then your radius is going to change in relationship to where that line is, okay? But for now, right now, your radius is going to be just the y or just the x. Does that help a little bit? Does that make sense? Thank you for that question. Other questions? Are we ready to go around different line then, guys? Okay, and then we're going to put it all together. All right, let's see. Let us go to example number 5, right here. Use the method of cylindrical shells to find the volume of the solid obtained by rotating this region about the line x equals -4. So we've got a region y equals x squared, x equals y squared, both of which are what? Parabolas. How do you know they're parabolas? Because they're squared. Beautiful. So we've got a parabola facing upwards. We've got a parabola facing downwards. Get me those, not downwards, sideways, right? So get me an upwards parabola, get me a sideways parabola. Got me upwards parabola, sideways parabola. They're going to hit at 1, 1. So it's going to be a super small region. We did one of these before, right? I think we did one of these with washers. I think we used washers on a problem like this. This time we're going to use shells. So we got a y squared and an x squared. Y equals x squared sits up. X equals y squared sits sideways. And we're going to take that region about a vertical line, x equals -4. So let me see what picture we're getting. So if I'm going this way, I have y equals x squared. And the other way is x equals y squared. Now I want them to intersect, so I'm just going to ignore everything else and just focus right there in the first quadrant up here where everything is positive. I've got x equals y squared and y equals x squared being my two curves that are bounding that region. I also want to put in that axis of rotation because I'm going around the line x equals -4. I'm rotating around a line that's similar to a y-axis. So if I'm similar to a y-axis, you should be asking yourself this question. So if we're similar to the y-axis as we rotate, what should we be cutting perpendicular to or integrating with respect to? Dx. Beautiful. Thank you. Because we're going around a y-axis, we should be cutting perpendicular to the x. Dx. So everything should be taken with respect to x. So our limits are going to be x limits, and our functions have to be rewritten y equals. So that tells me I want to rewrite this and only look at the positive square root of x part. So when we go to set this up, and let me just draw my picture in, I'm coming over 4 units, so I think I'm going this way if I'm going to do that in. It's coming around. And so let me actually make this all in blue, like this. This is the piece when I rotate, right? So it's a bracelet. We did one of these last time, this big bracelet, right? But this time we're going to look at it and calculate its volume using a shell method. So to get my cylinder, again, I randomly cut perpendicular to the x-axis. That's because that is the opposite variable. Since this is like a y-axis, I'm cutting perpendicular to the x-axis. So when you make your cut and draw your cylinder, that cylinder is going around x equals -4, but it's going parallel to it. So that cut is right here. That's my cut. And that cut helps me to identify both my height and my radius. My height is this distance right here. Top function minus bottom function. Do you see that? Top function, my height is this distance right here. My top function minus my bottom function for that cut. So what's my top function? Square root of x. What's my bottom function? X squared. So the height for my problem is going to be, the height is square root of x minus x squared. That green's not very good. I need a darker green. My radius is the distance from the axis of rotation to the cut. It's the distance from the axis of rotation to the cut I just made. This is where it gets tricky. This measurement here is the x value 1/2. It could be any x value, but I happen to put it right here at 1/2. That is measured from 0. X is measured from 0. This little distance here is a distance x. Last time I said think of this line as being the line x equals x if you like to talk about right to left as far as distances goes. But this is x equals x. X equals 1/2. X equals 3/4. X equals 7/8. X equals x, whatever I choose it to be. So if I want to get my radius this time, I have to take x and subtract from it the distance to get to the other axes. Right minus left. Are you with me? So the right side is x. The left side is -4. So my radius, do you see, Patrick, on this one, how the radius extended? So my radius actually turns out to be x minus -4 in this example, or x plus 4. So those are my pieces. Let me put it together. Volume equals the integral from 0 to 1, 2 pi RH dx, because we're cutting with respect to the x-axis, 2 pi r in this case is x plus 4. And h is my square root of x minus x squared. I don't want you to work it out, okay, guys? I just want you to set it up right now, just because I want to practice a couple setups, okay? Does everybody see, though, where that radius has come from, this radius, how it came? It changed because I wasn't going around the y-axis. I was expanding and making a bigger radius. This normally would just be my x distance. Well, now it's x minus -4, or x plus extra 4 units to make it bigger. How are we? Questions? That's tricky. That's the hard part. Students always miss this. New one? Any questions? Oh, where'd it go? Oh, maybe I don't have another one. Do I not have another one on there? Oh, I don't. Oh, do you guys want to practice another one? Let's practice another one. Let's take that same region. Okay, we're going to practice another one. Okay, ready? All righty. I need to add a second practice. Here we go. We're going to practice the same region. Okay, so we're going to take the same region. That is the region bounded by y equals x squared equals y in the first quadrant, okay? In quadrant 1. So we're going to take that same region. But this time, hi Alex, how you doing?
All right, sorry I'm late.
No worries. This time, I'm going to take that region and I want to rotate, boom, boom. I want to rotate it around the line, let's see, y equals 3. X equals, oh, yes. Yes. Thank you. Thank you, thank you, thank you. X equals y squared. Thank you much. I wrote the same thing twice. I did sleep last night. I just did that NyQuil again. I swear, I think it just messes with your brain. Do not take NyQuil before a test, ladies and gentlemen. I'm telling you, it just messes with those connections. But you do sleep, I'll tell you that.
You have to use
The melatonin gummies, Max.
No, literally, I use
Does that knock you right out?
it does a pretty good job, yeah.
Gosh, if you guys can sleep, I am so envious of you. If you can just go to bed and sleep at night for a full 6 hours. Oh, God, I just want to be you. That's all I can say. Oh, ouch, ouch. Can you catch up like tomorrow?
Probably not.
This weekend?
Probably not.
Oh. Is your roommate too loud?
Yeah. It's in Minecraft.
Oh, yeah.
My roommate's pretty loud.
Yeah. Oh God. You guys get excited to it. I see your roommate. Oh, are you loud at night,
I'm the
Quinn?
loud one.
Guys, we're taking this region. We're going about the line y equals 3. What's your favorite part of college? It's not classes, I know that probably. It's probably just the whole experience, huh?
It's a lot of the feeling of like just being independent and
Being
being
independent.
decide my own schedule.
Yep, absolutely. Not having your mom say, go to bed. Turn that off.
Well, yeah, that and you don't have to worry about waking up your parents when you're up at 2 a.m. in the house.
There you go. Absolutely.
Because your sleep schedule's beyond fucked.
Okay, guys, so on this one, we are going about the line y equals 3, okay? Y equals 3 is a horizontal line. It's like an x-axis, right? It's like an x-axis. When we do shells, we integrate to the opposite variable, right? So we are going to be integrating not with x, but with y. So we should be integrating with respect to y this time, okay? So we'll walk through that step again. Everybody's thinking this y equals 3 acts like an x-axis. And therefore, we have to integrate with respect to the opposite variable because we cut parallel to the axis of rotation or perpendicular to the other axis. So when you draw your cut, you're going to be cutting horizontally like this, side to side. And your shell this time, I'm going to bring it all the way around, is going over here. This is where the shell is going this time. It's coming up because we're going around this axis. That shell has a height and it has a radius. Your height is measuring left to right this time, right? It's measuring this way. This is my shell cutting with respect to y, cutting perpendicular to y. dy means cut perpendicular to y. This distance is right minus left. You need to make sure that your equations are rewritten x equals this time. X equals. So this guy's going to be x equals square root of y. So my right function is going to be square root of y, and my left function is going to be y squared. My radius measures from the axis of rotation to the cut. Remember, it is just a random y value. You can think of it y equals whatever number or y equals y, right? It's just this y value right here. Y equals whatever y's got to be, okay? So you're going to tape top minus bottom. My top function is y equals 3. My bottom function, again, is just this random cut along the y-axis. Y equals whatever y value I choose. And so that means your radius should be 3 minus y. Two pi RH simply becomes 2 pi times my r value, 3 minus y, times my height, right minus left. Any questions? Any questions at all?
Could you please go over the 3 minus y again?
Absolutely. Let's go over that
Why
again.
it's not y minus.
So, yep, there's a couple things. Let's talk this. Let me do something like this for a second here. So say this is 3 units, okay? This is 3 units, let's just say. And let's say that I am going to make a mark right here at a half, okay? And instead of getting a radius that's all 3 units, let's say I want this distance right here. What's it going to be? It's going to be 3 units total, right? Minus this little half piece. So it's going to be 2.5, right? And how do you get that? You take the whole 3 units and you subtract off that little piece that's on the bottom.
But with x, it's the opposite.
So here's the difference. Let me do it this way. This is 3 units. The radius that I'm talking about is not the entire 3 units. It's a little smaller, so it'll be 3 minus. Whereas on this one, my radius is actually a little bigger than 4 units. You can see it, right? It's 4 units plus an x units. So you could look at it that way too. It's a 4 unit radius right here plus a little bit extra. So you could think of it that way too. 3 units, take away a little bit. 4 units, add a little extra. Does that sound good? Yeah. I like it that way too. I like to think of it that way. That's a good way. Any other questions? How are you guys? Ready to do a worksheet for me? I want you guys to get practice with this.